Hey everyone, so I just wanted to go over um uh, the differences between a microcontroller and a Raspberry Pi. So there are many different devices on the market which share functionality, or let's just say share microcontroller like functionality. For example, there's a BeagleBone Black, BeagleBone Green, Arduino, the Texas Instruments launchpads, etc., and of course the Raspberry Pi. So the Raspberry Pi is already has already risen to stardom. This is one of them at least, as one of the most popular devices used for you know control related applications. Gpio then. So um that its rise in popularity has led people to um, ask why, um, well, which device they should buy for whatever application they're doing. So I just wanted to quickly go over the functionality and disadvantages of the Raspberry Pis. So, for example, but first, GPIO is general purpose input output. So what it enables you to do is write a program that switches pins on Raspberry Pi on or off. I'm not sure if you can see the pins clearly. Oh yeah, not very clear. Sorry about that. But yes, so the pins can then become connected to transistors, and then if you switch a pin on, then it will basically trigger the transistor, and then that transistor could turn on a relay, for example, which could turn on an appliance, for example. You could that could switch on your washer, for example, or you could do something a little more advanced and um, dedicate each pin to a certain function within an appliance. So you might use one pin to switch on the water pump, the sorry, not water pump, the fill. God, what's that called? Okay, I don't even know what it's called. Just to start filling the machine, and then you could have another one switch on the spin cycle or the wash cycle, drain, whatever it is, right? So there are many things that you can do with a Raspberry Pi. It also has internet access, and it can be used for various networking functionalities. You can use it to build ad blockers. There are so many different things you can do with a Raspberry Pi. So Raspberry Pis are extremely broad in their capabilities, and there's very little that you can't do with them, right? So, aside from the fact that Raspberry Pi could easily cost you, well, I think, depending on which model you buy, it could be $25, $35, or you could even get one of the smaller, more stripped down ones for even less than $25. But so this is where people start to get a little confused, or they just don't realize the Raspberry Pi power consumption is dramatically higher than pretty much any microcontroller out there, or any of the major microcontrollers. So an Arduino is a microcontroller, Texas Instruments launchpads are microcontroller kits rather, and the EFM series from Silicon Labs is as well. So over here is a battery, right? So I'm just gonna show you a battery this size, or well, to be comfortable larger, is required to power a Raspberry Pi for a reasonable amount of time without having to recharge it frequently. So yeah, that's not a small battery really. Compare if you're, or maybe it looks small to you but let's look at what it takes to power a microcontroller, right? So this microcontroller, which has well, almost limitless Gpio functionality as well, but no internet access built in, although it can be connected to a device to give it internet access. It can be powered by a coin cell battery, which is very tiny. I'm not sure if you can see it properly, but yeah, it's a 2032 coin cell battery, which is exceedingly tiny compared to what the Raspberry Pi requires. So, of course, that's not the most important detail, because the Raspberry Pi is well, what's the word now? It's not just about the size of the battery required, because you may not necessarily be giving it is providing it with its own battery. So let's look at automotive applications now, right? And not just automotive, but anything that plans or anything that might be running all the time, and it really needs to consume as little power as possible in its standby state. And that's where the microcontroller wins. And there are other advantages to microcontrollers as well. So, for example, this is the EFM8 BCB microcontroller by Silicon Labs. So, what is so these are the Gpio pins. Looks similar to the Raspberry Pi. So, what it can do is essentially run on microamps of power, if configured to do so. And if you're using it in an automotive project, and this is actually for intended for automotive use, so not strictly, but it's one of the models cleared for that kind of usage, or deemed suitable for automotive usage. That means that it can run off a car battery for a very long time without killing it. Raspberry Pi, on the other hand, if you had that running in your car with the engine off, it would kill the battery in no time. So Raspberry Pi can consume up to, okay, forgive me if I'm wrong, but can consume more than 10 watts of power, although most of the time it's less than that. You're looking at more like 2 to 5 watts with idle, if you're factoring in idle time and more normal usage then. So the automotive battery problem is definitely significant. So the EFM8 has no issue, is not an issue for your battery. Raspberry Pi is, but there's also reliability, right? So Raspberry Pis are well built, as are the EFM8s, but the Raspberry Pis run an operating system instead of just firmware. The EFM8 and nearly every microcontroller runs firmware, right? Firmware runs without an operating system. It's just, it runs on its own then without an OS. So when you turn on EFM8, it just starts executing the firmware, right? If you turn on a Raspberry Pi, it has to boot into an operating system such as Linux or Windows 10 actually. Not early versions of Windows, and you have to ensure that it doesn't shut down improperly, because if it shuts down improperly, it may not be able to start back up. So that's important as well. So a power outage could cause technical issues like that. It can cause technical issues with a microcontroller, but it's less likely though. And a microcontroller tends to recover very quickly, meaning if there's a power outage, and when the power comes back, microcontroller simply resumes operation. It doesn't crash and then have to go through a process to boot back up or anything. It just instantly resumes operation and it turns back on. So there's no boot process really. And so this is another microcontroller. So this series, the Hercules series, consumes more power than the EFM8, although still vastly less than a Raspberry Pi. However, it is also far more powerful in terms of its capabilities. Unfortunately, I can't remember how many Gpio pins it has, but it's is many. They're not even all shown here on the board. These are just the headers for testing, but there are actually many more. There's hundreds of Gpio pins actually. But anyway, so so yes, there's a reliability aspect and power consumption. So it actually matters, and there's also size, right? So let's get back to providing each device with its own battery now to sustain it. So the AFM8, okay, so here's the next interesting thing about the AFM8 now. That's the AFM8, right? That tiny little chip there. I'm not sure if you can see it. That tiny black one. Yes, it's incredibly tiny. And it's not much thicker than a, well, it's about the thickness of a credit card, or possibly less. And so all of these parts here are for programming, debugging, and well, ease of connection to the microcontroller, right? So this board, basically 90% or more of what you're seeing is just to make it easier for me to write the firmware for it and load it on. So in reality, in production, an AFM8 project could be very tiny, right? Significantly smaller than what you're seeing there, and it could use less power as well. So if it is used in a, so it could have a size advantage over the Raspberry Pi. I'm not being fair to the Raspberry Pi here because the case adds to its thickness, but once you add the battery and whatever power source you're using to recharge that battery, although not that big, the Raspberry Pi does get a bit bulky, right? So if you have a very tiny project and you want to fit it into something the size of a watch, for example, or if you're making something, there's something very tiny, a tiny handheld device, then the microcontroller is obviously going to be significantly better. The Raspberry Pi will actually be out of the question in that case. So I just wanted to clarify the importance of the differences between these devices, because we're talking about milliwatts of power consumption at the most for microcontrollers, but for some of them, like this one, this could be in the microwatt range, and for the Raspberry Pi, it's several watts easily. So these things do matter, and well, you should also consider the heat output of the Raspberry Pi. It's considerable. So if you're going to install it in something that doesn't have much space for airflow, you're gonna have to take that into consideration, because it well, the thing is, it's possible to operate a Raspberry Pi without a fan, although that's not ideal. In some cases it can get hot depending on how much you utilize the CPU and the GPU. So yeah, that's pretty much it. The FM8 is also able, well, it's cheaper than the Raspberry Pi if you want to start thinking of it in terms of what you'd actually need in production without the board. But this board cost me $28, and this Raspberry Pi costs $35. But the EFMA microcontroller itself, it costs last time I checked, it was $1.23, but that was years ago, and prices are subject to change. So yeah, that's going to be less than a Raspberry Pi, and of course it can fit in something the size of a keyboard, or it could even squeeze it into something, what's the word now, if I wish I could find a better example. But yeah, it's very tiny, and it opens a window of opportunity to make devices that fit in the palm of your hand. Even a device the size of it could fit in a device the size of my thumb, along with the battery and everything. So it has that advantage. Right, so yeah, low power consumption is absolutely important, and high power consumption is a deal breaker in many applications, not just automotive one, but anything that's running on a very limited power source, such as a battery for prolonged time periods, and isn't going to be plugged in regularly or at all, like a car. So yeah, so don't ditch your microcontroller for a Raspberry Pi. Although I should add that Raspberry Pi provides the benefit of convenience, because you can use a broad variety of high-level programming or scripting languages to do Gpio on the Raspberry Pi, for example Python or Node.js, and there's C as well. Of course, C is widely used on microcontrollers as well, including these two, but Python and Node.js, well, they make it easier, to be honest. So I actually wrote a Raspberry Pi Gpio tutorial, and one for the FM8 as well, and another one for this to turn it into a PWM fan controller. You can find all of those on compulsor.com. Thanks for watching.